Hello everyone, I am Anirban Bonik from Presidency University, Kolkata. Today we will discuss about the molecular dynamic simulation of transmembrane protein, and we have taken the example of GPCR on GPCR protein, G protein coupled receptor, the ADRB. I have previously downloaded the crystal structure of ADRB from pdb.org, and now I will show you how to simulate and equilibrate such a transmembrane protein using VMD and the graphical user interface of NAMD. The main reference here I have used is the NAMD membrane tutorial PDF. So all my files have been previously loaded in my downloads. So here we'll go into downloads and my MD3 folder over there, and under my MD3 folder there is a folder, another folder MD, where is my PDB file, the ADRB is present. I've opened the VMD, and after opening the VMD I have opened the TK console, as you can see, and I am changing my directory into my download MD3/MD folders. So you can see CD, that is changing directory in C, users, Anirban, downloads, MD3, and finally MD. And we actually can check which files are present in that directory by typing ls. Now we'll select the ADRB molecule over here. We're actually trying to generate the PSA or the protein structure file from the PDB file, and in the input we have the ADRB.pdb, the output base name. We'll keep it ADRB for simplicity, and after output base name we'll add the topology files, and we'll click on load input, and after that the guess parameter button, and finally we'll select the chains. We'll create the chains. Here is no chain, but if there are some chains, we'll finally apply the chains, and finally we'll finish the protein structure file formation. And here we have created the protein structure file of the ADRB from the protein data bank file. Now we'll build the lipid bilayer from the membrane builder plugin of BMD. We are using an 80x80 lipid over here under C27, that means charm 27 parameter. So we have successfully created the membrane patch. It's a POPC membrane patch, artificial membrane patch, and this is the lipid bilayer, lipid membrane. So essentially we have now the ADRB PDB and ADRB PSF and POPC PDB and POPC PSF, these four files. Now we'll set POPC and then a space within third bracket. It will be atom select top all. That means the top structure here is the POPC structure, and we have selected all the atoms of this structure. Now set space ADRB mol space within third bracket mol new ADRB.psf. So essentially we are loading the ADRB PSF file, which contains all the ionic interactions and informations on the bond of the bonds of the structure. Now mol space add file space adrb.pdb. We are loading the PDB file of the protein on top of the PSF file, and here the protein file has been loaded. Now set space adrb space within third bracket. Let me check once, and it will be atom select dollar adrb mol all. We are selecting the adrb mol over here, and in the next command we are going to type $POPC move by space within third bracket vec invert, that means vector invert, space within third bracket measure center in between space. After center there will be a space $POPC space weight space mass third bracket, and the second third bracket to select the entire command. So essentially we are aligning the protein and the lipid with respect to their center of mass. Now we'll go for the next command. Let me check once. So it will be $POPC write PDB. So we are essentially trying to create a PDB file. POPC underscore temp, so it's a temporary file .pdb. Now the next command will create another temporary file of the protein, but before that we need to align it. So our next command will be to align the protein with respect to its center of mass, just like the lipid we did before. So again $ADRB, which is our protein, move by the same command like we did previously within third bracket. It will be vec invert or vector invert a space, and within third bracket, the second third bracket, we'll type let me check once. It will be measure and then space and then center and then space again, and it will be $ADRB space weight space mass third bracket and then again third bracket, and we'll hit the enter. So it is very essential to keep all the spaces in between the words, so it has been aligned with respect to its center of mass. Now display space reset view, and we'll hit enter after this command. In any command line type of operation, it is very important to keep in mind all the letters, whether they are in caps or whatever. So here we can see that the membrane and the protein have been aligned. We are changing the representation so that the protein becomes much more visible inside the lipid bilayer. Both of them are in the same field, and the protein has been inserted in the lipid bilayer, but till now both the structures are separated. They are separate. As we know, the lipid bilayer, we have created the file POPC underscore temp will now create the protein file, that is ADRB temp, and after that we'll merge them to create one single PDB and PSF file where the protein will remain inserted like this in the lipid bilayer. So it is just after the alignment. We have not yet created a single file where the protein remains inserted in the lipid bilayer. So our next aim is to create the protein underscore temp PDB where the protein remains aligned with the lipid bilayer. So we will go to the command line again, and our next command will be, let me check. So after display reset view, it is going to be $ADRB and write PDB in between space, and after write PDB there will be a space. ADRB underscore temp.pdb. So these two PDB files, ADRB temp and POPC temp, they are separate files, but both of them are aligned with each other with respect to their center of mass. After that, we'll merge both of these files to create one single PDB file where the protein remains inserted in the lipid bilayer. So in the next command, mol delete all, so we have essentially deleted all the molecules loaded in the window. Now package, this is a very essential command, package space require space PSF gen. So we are going to create a PSF file over here. Reset PSF is the next command, so it will clear all the previously loaded topology, structures and all. Now read PSF and a space POPC.PSF. As you can remember, we have initially generated a POPC.PSF and a POPC.pdb file. Our next command will be coord pdb space, and it will be the PDB file of the lipid bilayer, that is the POPC underscore temp we have just created .pdb. So it will be loaded on top of the protein structure file of the lipid bilayer, and we are going to load the POPC temp .pdb file what we have just created a few minutes back, and we'll hit enter over here. Our next command will be here. Again read PSF space adrb.psf. So here we are going to load the protein structure file of the protein, the ADRB, and on top of it we are going to load the PDB file of the ADRB temp that we just created, the aligned protein data bank file of the ADRB. As both of them are loaded, we'll create a protein structure file as a merged one, which will contain both the lipid and the protein. That's why we have named it ADRB underscore POPC underscore raw, but it is a PSF file, and after that we'll use the command write pdb ADRB underscore temp underscore raw dot pdb, so to generate the protein data bank file. We have used the raw because we have to modify these two files to get the final files. Now file space delete space adrbs underscore temp.psf to delete the psf and the pdb files. So here we have deleted the pdb file first, and the next command will be file space delete space adrb underscore temp.psf, as we don't need them anymore. In the next command, mol space delete space all, no molecules loaded, as there were previously no molecule loaded, so it is showing like that. In the next command, we'll type mol space new space adrb underscore popc underscore raw dot psf. So we are trying to load the psf file, that is the protein structure file of the adrb popc raw. On top of it, mol add file, we are going to add the pdb file of adrb popc raw. As I was saying that we have used the term raw because we need to modify these two files, I mean the pdb file, and then we'll get only the final file. After loading the pdb file, set space popc space within inverted comma res name space popc inverted comma closed, and then enter. Now our command will be set space all space within third bracket atom select top all third bracket closed. So we are essentially selecting all the atoms of the top structure. That means the structure that is loaded right now. $all, because we have selected all for all the atoms, and then space set space beta 0. So essentially we are selecting beta, a parameter, value 0 for all the atoms. And now in the next command it will be set space cell text 1 all in small space within inverted comma. The command will be $popc and then a space and space same space residue space as and after as there will be a space slash and it will be within bracket name capital P1 in between space and then space and all in small, again a space, Z will be greater than 0. After that and space ABS X. So ABS on X-axis will keep it less than 15 and will keep the ABS on the Y direction also less than 15 in this cell text 1 command. 1 inverted comma and it is done. We'll hit enter over here. Let me check once. It's a big command. I think it's done. So everything is POPC and sensitivity less than 15. and here we have. Alright, I will select the text 2 just like the previous one. So we'll type set cell text 2 within inverted comma. We'll type again $POPC space and space same residue as spaces in between the words. So you have to keep this always in your mind, and then there will be a space and slash within bracket. It will be name space capital P1. Here we will change the parameter again, and then space will keep z less than 0 over here in this command, and then a small space, the word and all small, and then space ABS on the x-axis will keep it less than 10, and then ABS on the y-axis will keep it less than 10. We'll close the command with a single inverted comma as the entire command is selected. So let me check once. So select and everything z less than 0. Done. Now next command, set cell text 3. We are setting our third text and one inverted comma $POPC space and space same residue as, then a space, and over here is within 0.6 of protein. So essentially we are trying here to remove all the bad lipids, creating steric mess, creating steric hindrance with the protein. So we'll do the same for a thin water layer on top of the lipid bilayer and below the lipid layer. After these commands, set cell text 4 but before that we are using this command, set cell 1 and within bracket atom select top $cell text 1. So essentially we are selecting our cell text 1, and after that we'll select all our cell text 2 and cell text 3 just as the previous one. So set cell 2 within third bracket, it will be atom select space top space $cell text 2, and we'll close the bracket, enter, and finally set cell 3 within bracket, it will be atom select space top space $cell text 3, and we'll hit enter. As I was saying previously, we are doing this for bad lipids, creating steric hindrance with the protein. and we will do the same for the bad water molecules also. And after these three commands, we'll go for our next command, that is $cell1 space set space beta1. Enter, and then $cell2 space set space beta1, and we'll do the same for our cell text 3. Now our next command will be set space bad lipid space within bracket it will be atom select space top a space within inverted comma it will be name P1 and then beta greater than 0. So P1 stands for all the phospholipid head groups of the lipids, and we are essentially here selecting the bad lipids with respect to the parameters we defined in the command lines, and after selecting all the bad lipids we'll delete them. Now our next command will be set space seglist lipid, and then there will be a space within third bracket dollar dollar and bad lipid and a single space, and then get seg ID. So we are going to get the segment IDs of the bad lipids after this command, and we will hit enter over here. So everything is okay, and here are the IDs. Our next command will be set rest list lipid within third bracket there will be dollar bad lipid get res ID. So we're essentially going to get all the residue IDs after this command of the bad lipids, creating static hindrance with the protein. Now we'll do the same for the water molecules, creating bad contact with the protein molecule, as I have said previously. And our command will be set cell text 4 and a space within inverted comma and first bracket. The command will be water and not segname. So we have to provide the segnames all in caps, WCA space WCB space WCC space WCB space WF and then a space solve. The bracket will be closed. There will be a single space and then slash. There will be and after and same residue as within, then space 3 space off, and then again a space and then slash. Let me check, it's a big command. Is there any space? Okay, getting confused. Space, let me try. Within bracket, same residue as, then a space and then bracket, name P1 and beta greater than 0. It's a huge command. Then one bracket and second bracket, space or protein, and we'll close the command with a first bracket and thus inverted comma. Enter. We'll hit enter. Let me check once. The command, it's a big command. Name P1 and beta greater than 0. Alright, within 3. I have a doubt on the space after 3 off, whatever. There will be a space, yes, and after the slash there will be no space, so it will start the first bracket immediately. So we'll hit enter. Just after the inverted comma, ending the command, and it went fine. We'll go for the next command, that will be set cell text 5. This will also be for the bad contact water molecules. With the inverted comma, we will write down segnam space solve, all in caps, and same residue as a space, a slash, and after without any space, within 3 of lipids. So there is a space before the slash, but there is no space after this slash. Generally this rule goes well in these commands of VMD. I've checked that before. Closing the command with inverted comma, and we'll hit enter. I need to check the command once. Okay. Hopefully it will be fine. Enter, and it went fine. Now, just like previously we have done, set cell 4 within third bracket. It will be within third bracket, it will be atom select top and then a $sign, then cell text 4. So essentially we are selecting the cell text 4 for the bad water molecules, creating steric hindrance with a protein. and we'll close the command, will another third bracket, and we'll hit enter over here. And there is some problem. What is the problem? I think there is a problem in front of the AND. Let me check. What's the problem? Let me see. Probably it cannot recognize the AND over there after the slash. So probably there will be a space, I think. Let me check. It is such a huge command. It's a little bit difficult, as I am also a beginner in this field and I am trying to sort all these out myself. So I am putting a space. Let's check what happens. Oh, finally. So there will be a space before the and after the slash. So I need to put the next command again. With that I will just directly copy and paste the second command over here and enter. So enter went well, and the set cell 4 command directly I will copy and paste and will hit enter. Fantastic. Now set cell 5 within third bracket. It will be again atom select top and $cell text 5. So we're essentially providing all the parameters, different parameters. We're telling the software that which water molecules we do want and which water molecules which we don't want. Same goes for the lipids. So we are selecting the bad lipids and bad water molecules, and then we will delete them. Our next command will be cell 5. Don't select top $cell text 5. So it will be $cell 4 a space set space beta space 1. So we are keeping the beta 1 here, just as we did for the POPC lipid bilayer, and cell 5, so $cell 5 set beta 1, same. And now we'll get all the segment IDs and the residue IDs of these bad contact water molecules. Set bad water, we're selecting the word bad water as the function of within third bracket atom select top. We are mentioning what we want within inverted comma, name OH2, that means hydroxyl, and beta greater than 0. That's all. Inverted comma closes the command, and third bracket closes the enter command. Enter, and now our command will be set space seglist water, and there will be a space within third bracket. We will put dollar and then bad water space get space seg id, third bracket, enter. So a lot of water molecules are there, creating steric problem with the protein. And then set rest list water space within third bracket $bad water space get space res id, third bracket, and enter. So we have now selected all the water molecules and POPC molecules which we do not want, and our next commands will be to delete all of them from the initial raw file of ADRB POPC. Next command, mol delete all, to delete all the files loaded. Reset PSF. We have used these commands before. Now we'll use the command to load the PSF file of the raw ADRB POPC merged one. So it will be reading a PSF file. So creating some problem. My laptop is getting slow. Just a minute. What's the problem? It's creating problem. So read PSF space ADRB underscore POPC underscore raw. So this is the raw file .psf. Enter. And then coord pdb to load the pdb file on top of the PSF file as we did before. ADRB POPC raw .pdb. And after loading them, we'll use the command the delete command, that is FORESCH 4SCH a space. We're mentioning all the segment and the residue IDs over here. So seg ID space $seg list lipid. So we are selecting all the segment list over here. Then a space res ID will be $res list lipid. So we are selecting the residue list of the bad lipid molecules. And a space within second bracket, essentially we'll use the command del atom a space $seg ID and a space $res ID, and we will close our command with a second bracket. It's done, and we'll hit enter. So delete it. We'll do the same for the bad water molecules again. So the command will be FORESCH space seg ID space $, no, a $, it's a second bracket, oh sorry, a $, seg list water, so after seg ID then $seg list water, and then res ID, then $res list water, so there will be spaces in between words. You have to keep this in your mind all the time, and then there will be a space, and within second bracket, just like we have done previously, there will be the command del atom and then space $seg ID and space $res ID. So I'm typing them. Now I will close the command. We'll hit enter to delete the molecules. So essentially I have deleted all the bad water molecules and the bad lipid molecules. So essentially I have created a cavity, a space in the lipid bilayer for the protein where it can reside. The protein can reside perfectly. So write PSF ADRB POPC. This is the final file, the final merged file .psf. So we are essentially creating the protein structure file first, and we'll hit enter. It is done, and then we'll create the PDB file. So we'll use the command write PDB a space then ADRB underscore POPC.pdb, and we'll hit enter. So it is done. So now, till now, we have done two files, ADRB POPC PSF and PDB protein data file. Now I will check them. So mol new ADRB POPC.psf. So loading the PSF file, and on top of it mol add file space ADRB underscore POPC.pdb. So you can actually now see the perfect cavity in the lipid bilayer. It's a top view, and the protein inside in the core of the lipid bilayer. This is the top view, and it is absolutely perfect. So we have done it absolutely perfectly, and so our next aim is to solve this structure. But before that, we are changing the representation so that you can understand it better. So ribbon structure, new cartoon structure, sorry. And so this is my first tutorial, the first part of tutorial, where I have created the lipid bilayer and we have successfully inserted the protein into it. My next tutorial will be to solve this entire system. So the extracellular and the intracellular domain of this membrane protein will be in the water layer. So that's it for this part 1 tutorial. So I'll be back again in my next tutorial where I will show you how to solve it.